Okay, awesome. Hey guys, so I'm not sure if everyone can hear us. Let me see if I can be broadcasting now. Basically, just going to go through some details on cloud penetration testing, go through some scenarios, some of the common attack vectors we see, some of the case studies of how you can get into trouble testing a cloud instance like you do an on-prem instance, and some of the things that you can find by doing deep penetration testing of cloud environments, and pivoting to talking about how to do those approaches and what they look like. So really can iterate through those kind of three things here, the attack vectors, the case studies, and the pen testing approach in a couple of scenarios. Then can go into some details on a number of considerations. Additionally, not only directly related to some of the cloud stuff, but some of the pen testing approach and some of the gotchas you need to watch out for from both a security and compliance perspective. So you've got myself on the line. I'm Kevin. I'm one of the lead pen testers here at Tevora. We've also got Miguel Martinez, who is one of our lead red teamers. Basically kind of hop in and discuss some of the things we've seen here, and again, go through some of the items here on the cloud side. So essentially, just a quick introduction, at a high level, what's different from when you're looking at scoping an on-premise pen test versus a cloud pen test? A lot of things are very similar, but you do have a pretty big difference in scope definition, oftentimes transferring from talking about sets of subnets, live hosts, to talking about cloud native services, Lambda functions. In many cases, your cloud environment may map and just be a similar kind of copy of an on-prem that's moved into an Azure or into an AWS. But even then, there can be differences. For example, IPs tend to be more ephemeral, where you don't necessarily have defined static addresses, even for public IPs. Domains and host names tend to be the more static pointer to that scope. So you do have some of those considerations, and the cloud native services is a huge one as well, where you're not only targeting, hey, I have a system running on bare metal, or maybe I have a collection of Docker containers on bare metal. You can obviously spin up compute instances, but you do have a lot of folks that are using things like Lambda, where you're basically running code serverless in the cloud and not relying on necessarily a server to handle those things, as well as wiring it all together with static HTML hosted on S3 buckets. And you get the picture, right? When you're looking at scoping and testing the cloud, oftentimes there's a lot more that can go into making sure you've got the right targets than just a list of host names. You also have, what's interesting, implicit machine level accounts, and that's something we'll get into in one of our scenarios. This is actually similar in many ways to kind of a traditional on-premise system that's tied to Active Directory. There are, when you get onto an EC2 instance, let's say you've compromised a system, there are rights that system has to your AWS infrastructure. And oftentimes, because of the level of automation that's being deployed when you're talking about orchestrating your cloud environment, the privileges that these systems have can sometimes be devastatingly high. Now, of course, many applications, you may be a security model where if that server is compromised, they have access to the DB, they have access to everything. But particularly for customers and clients that are doing infrastructure level tenant isolation, it's really important to take a careful look at what the implicit machine level accounts you're giving to your machines are. And a common thing, in AWS parlance is, you have basically an IAM role for an EC2 instance. And again, once someone has access to that host, they can basically assume that role either directly on that host or query the metadata endpoint for credentials to then use in most places from the public internet. And the DevOps and automation, again, that's something where it's a huge opportunity for attack. There are a ton of benefits you get from orchestrating things in the cloud and being able to leverage these cloud native services and really be agile in not only deploying new code, but also scaling. But a lot of times these can be targets for attackers. And so we'll go in and walk through how someone might target these items. So first thing we want to talk about, an application test, right? What are the attack vectors for an application in the cloud, and how does that look different from what you might see from an on-prem application? Well, in many cases, it can be very similar, but oftentimes, and this is something that as people have kind of firmly transitioned, and they have now not only just a copy of their previous on-prem stack, but they're starting to really dig into cloud native functions, right? Maybe you're using EKS to have a ton of Kubernetes instances to manage deployment of containers. Maybe you're using Lambda functions. You're going fully serverless. We've seen a lot of folks, especially for lighter apps, like CDNs, or not CDNs, but CRMs, or things that are basically would previously maybe be a WordPress site with a lot of complication and plugins. They're finding, hey, just some static HTML and a few dynamic functions in Lambda can actually get us all the way there and avoid a whole bunch of hassle and configuration, right? Obviously, you have things like RDS with databases and API gateways, and of course some of the orchestration things that are built into the cloud, like CloudFormation. Oftentimes some of these things will be, obviously mapped to be a little bit more agnostic, where you may be using, broader things like Terraform rather than CloudFormation directly. But again, these things can all be at the periphery of, the application when you're doing an application test. And unlike, pen testing traditionally on-prem, where you have a pretty clear distinction between, okay, what is the application and what is the core server infrastructure, the lines do tend to blur a little bit, especially with, again, things being serverless. You start thinking about, okay, I have some application code running a container, and maybe I have some things running serverless on a Lambda function. Maybe I have a full EC2 instance that is still doing, kind of a traditional stack on there to process requests, and maybe they're all in front of API gateway or a load balancer. So when you start looking at, again, what the application looks like, it becomes important to bring some of that infrastructure into the application test, because if you're only looking at it from an application testing perspective, oftentimes you may miss some of the broader pictures and connections that an attacker is definitely going to key in on. One of the probably most notable things that we encounter, as well as many people, are issues with S3 or storage buckets. We'll get into that in the case study, but most applications in the cloud, that's one of the simplest things to first use as a cloud native service as storage buckets. Again, whether you're in Amazon or Google Cloud Compute, the concept's pretty similar. You can host static code, JavaScript, HTML, static resources in there, or you can even use it as a way to provide backing for user file uploads, right? If some customer wants to upload their logo or whatever it may be, S3 is a great way to support that. There's also things that you run into in the application that, traditionally would be very deep into your own application code. We see a handful of people now leveraging things like Cognito, and an AWS feature where you can basically use IAM rules and other things as an identity management for your application. And of course, you can go even beyond just the an infrastructure provider like AWS, and using things like Okta or Auth0 or others to provide this. And again, it becomes kind of a very coupled between, as you talk about infrastructure as a service and software as a service, it becomes very coupled with the functionality of the application, and so important to enumerate and test. And of course, client and server-side authentication to cloud infra, sometimes with, Cognito, that'd be directly happening on the client side. Sometimes you have, more privileged access on the server side to do things like orchestrate access to S3 buckets, and diving into those is obviously important to enumerate and test. And that's something I want to just kind of briefly talk over with a case study. We, for example, found an application that provided S3 upload functionality, file upload functionality backed by S3. And the way this worked was exactly what I just mentioned on the previous slide. The server had the ability, and it had credentials where it could orchestrate access to AWS. So essentially what the server was able to do is, when a client makes an upload request, it will give a signed AWS link to, that would be sent to the client, and then the JavaScript in that application could then process the upload to AWS, right? AWS would see the signed link, it's signed to do a put request or whatever it may be, and the client could upload something. This was, this is a great model. This is actually very similar to how a lot of things work, but you can get into trouble here. Basically found that there were insufficient input checking on the server side that allowed for overwrite arbitrarily of, specifically allowed for basically creating arbitrary signed S3 links that allowed for things like overwriting the actual static content of the HTML. So you can imagine, this could be a huge issue, allows potential takeover of the site once someone has an account where they're given file upload. So, and again, this would be something that's driving a customer exposed function that is designed to be there. And so the important thing on the pen test side, right, is to make sure these kind of things are looked at and covered, because again, it's something where the context and how it's working with S3 is really important, where you're kind of mixing that infrastructure and application to find something relatively interesting. And, one thing that's actually really great for the pen test approach here is, you always want to do for an application pen test, I always recommend doing credential testing from kind of the role of a standard user as a baseline, potentially 1 or 2 users at a minimum. But for cloud testing, it's good to go a little bit beyond that because, again, it's pretty hard to really capture in a scoping document what the infrastructure is supporting that. It's really great to have almost an audit or open box read level access to whatever the cloud infrastructure is. Because again, if you're looking at an on-prem application, oftentimes, okay, here's the server IP, here are the URLs, the vhosts, and credentials if needed, and go at it. Whereas on cloud, again, all those things I talked about are harder to kind of put down into a scoping document. They're harder to necessarily initially discover, though still possible, especially for things like the S3 bucket. But having that read-only access lets you do things like look for, hey, let's enumerate all the Lambda functions. Let's go ahead and look for all the routes to the main API gateway, make sure we have full coverage there, right? Without having to have an engineer on the client end go in and do that. Having that read access is very helpful to ensure you're getting a broad, thorough test at the same time. Server-side code is also really interesting. That actually S3 bucket issue was pretty obscure in the way we actually had to craft the request in order to make it happen. Again, it was just a flaw of input validation on how it was eventually crafting these requests, but the way it was done, it was something where it was difficult to discover with just fuzzing. We actually were able to find it because we were looking at the server-side integration code, and that's something where it's never a great idea necessarily to only do just read the code, right? But having code review, static analysis in concert with dynamic analysis and testing tends to be very effective in general because you can go and look at the source of truth and spend less time going through kind of enumeration and fuzzing. You can actually go through and see what's happening on the ground truth level. And for things where there are issues that, again, are a little bit more strange in how they show themselves, where maybe you need a couple steps or very specific kind of crafting in order to make it happen, those can be less evident through fuzzing. So especially if you're doing things like, we were mentioning in this case study where you are having the server have some level of credentialed access and it's kind of proxying and interpreting user requests in order to, handle those. Having a look at the actual code that's happening on there and the infrastructure interaction there actually can be very valuable in discovering those issues and making sure that they can't be exploited. Now on the flip side, right, an issue like that, if it's not as discoverable externally, the risk obviously is lower because if it's more difficult to discover from just kind of a pure fuzzing perspective, it's going to be less likely an attacker is going to discover it. But it's still one of those things where attackers have all the time in the world. They're going to be out there hitting this, and our goals in pen testing, what we recommend everyone kind of pursue is it is good to get that snapshot and understanding of, okay, well, how likely would it be for someone to discover this? But more important is the fact that you're able to know it's there and address it and remediate it. So definitely something we recommend there. Another cloud attack vector I wanted to talk about on the aside from the application side is compromised compute. So we've seen, this is not going to be relevant for all applications, but there are cases where once you've compromised a compute instance, you can pivot and escalate and get to a situation that's much worse than kind of that initial compromise would be if some other controls or things were looked at. And again, the reason I say it's not relevant for all applications, there are some security models where, if you get access to the compute instance, if everything's enforced application side, right, for tenant isolation, if it's a relatively more simple app, it may already be kind of the end of the line there, but there are many cases in customers we have where they do infrastructure-based tenant isolation, or they have more things than just this hosted here, right? And you don't want that compromise to potentially spread to other systems or to your raw infrastructure. And this goes back to what we initially mentioned on the basically account that's granted by default for compute instances. So specifically talking about AWS, you have an IAM account on the compute instance, and if I'm on a compromised server, one of the first things we're going to do is query the metadata endpoint. So if you aren't familiar with how a lot of these, I guess I'll just stick with AWS for now, but a lot of things work really similarly. But how AWS works in a lot of ways is the compute instances or EC2 instances, when you spin them up, they have a specific IP address that when they hit, AWS has a web service that will respond with information that host needs. So a lot of times when you're making configurations in AWS, you're actually just changing how AWS is going to present that that data and that web service and the metadata endpoint to the endpoint. And you have the cloud init and the cloud scripts, a lot of bash scripts, a lot of Python scripts that are actually doing the grunt work then on that system to implement the AWS configurations. So the basic idea of this then from an attacker perspective is we want to take advantage of that metadata endpoint, right? There's a lot of information in there. Most importantly, it's going to have the temporary security credentials that the instance uses to actually talk to AWS. So when you are on a compute instance, you do have that implicit role. And the way that an instance basically assumes that role, it still hits AWS endpoints through standard authentication processes. But what it does is it goes to the metadata endpoint and says, hey, what are my security credentials? The metadata endpoint sends that over, and then the system now is able to interact with AWS with the role you have given it. And why would a system want to interact with AWS, right? Well, orchestration, automation, right? Maybe you have some SSM parameters that you want to get pulled down and the system has access to. Maybe you wanted to see certain things in the CloudFormation template. Maybe you wanted to have access to S3 buckets to download cloud init scripts or provisioning scripts. There's a whole lot that can happen when you are on a instance and your automation is going to want to talk to the metadata endpoint. Now, one of the dangerous things about that is, obviously an attacker, if they're on there, they can go in and interact with it and, start doing those things from a credential perspective, but they can also just pull those credentials out directly and take them into their own AWS CLI and start interacting with AWS from an arbitrary location. Now that's why it's a good way sometimes to have IP allow listing on who can access that, have IAM rules to basically prevent, outside of that system from doing these things, but that's rarely in place. And even if it was, again, you can proxy through that system if it's compromised. But essentially, what that does is allow us to start looking through, hey, what's going on with the metadata endpoint? What access do we have to AWS? Doing brute force checks of, hey, can we try AWS EC2 described instances? Can we try AWS SSM list? Can we try AWS S3 list? And again, you could imagine if you've granted a system more rights than maybe it needs, that you could be in a situation where you can start to access a lot of things that maybe you shouldn't from just having access to a compute instance. And again, the reason why these have this access and why this access can be more than it should be is from automation, right? When you have provisioning that you want to happen, when you want to scale up systems, when you want to deploy them, you're not only leaving our automation artifacts behind that an attacker could potentially look at, but you're also potentially granting more rights than are necessary. The key thing is that it needs to work, right? And so oftentimes, especially when we're going into IAM and it's these huge amount of roles and permissions, it becomes easy to just say, okay, we need to give it access to SSM parameter store in order to get these parameters down without locking it down to the specific access that it needs. And then, of course, on the cloud compromised compute, you may also have a VPC with an internal attack surface. Depending on how that's laid out, that can be similar to targeting an internal network. But really, some of the interesting things are around the compromised compute and how you can leverage artifacts from provisioning, agent-based systems, as well as this metadata endpoint that we were talking about. So I want to talk about a case study there that's pretty interesting. So we compromised an application that had some remote code execution. In this case, it was a relatively complex application. So it was one of those things where they almost need to execute things like, this wasn't the specific case, but things like Jupyter notebooks or things that require some level of kind of heavy execution, right? So it's kind of hard to close off that vector. Some applications may be very simple and won't have a lot of vectors for RCE, but for those that do, oftentimes they're leaning into, okay, well, we know a customer could potentially be doing some heavy calculations on here. We have a high attack surface. We could have tenant, infrastructure-based tenant isolation, right? Well, we found that basically that this kind of all fell apart once we were able to get the code execution proof of concept. There were basically agent-based configurations installed that were, querying a kind of global registry of information. And again, because it's agent-based, we were able to see what's going on once we compromised that system because we could see all the details of the agent config and what it's receiving. We also saw, how the system was being provisioned from AWS. Some of the bash scripts running on boot that would bring the system up, and again, these were pulled from the metadata endpoint. Again, if you guys have ever spun up a system where you tell AWS, hey, I want you to run a script on boot, it's basically putting that in the metadata endpoint, and oftentimes people will have that just download an S3 bucket or something of that nature that they'll then have a more complicated script. But those are things that once an attacker has compromised it, they can look at that, and we looked at that, and kind of putting the pieces together, we can see, okay, well, here's the access that has to AWS. We can do some enumeration that maybe shouldn't have been allowed to enumerate what all the other tenants are in this area. And we can combine that with the agent-based system to basically say, hey, I want to get the configuration file for a tenant of this ID, which in this case happened to include passwords and other things that allow us to then get access to that tenant, do RC, so you can imagine, led to kind of a wide compromise of the environment. Now, one of the questions are for this, how do you approach that then from a penetration testing perspective, right? Because, on a pen test, you're not always going to get RC. And so we recommend doing on these, especially when we have infrastructure-based tenants, is kind of do a pseudo internal pen test like you would on-prem, but instead focused on simulating a compromise of a compute instance. And a great way to do this actually is just to send out, we typically send out a payload similar to what we do on a purple team where, hey, execute this payload on the system. Or you can give someone SSH or shell access in the same account of the application and look at what the potential impact would be from a compromise. Now, again, that's something where, this specific scenario may not be applicable for all types of applications. Again, I mentioned a lot of applications that their security model is built on, hey, it's all in the application layer, all the sensitive info is in the database, and it's kind of mediated by the application. Obviously, having access to that, it's kind of game over at that point. But again, for applications that are more complicated, that have infrastructure-based isolation, a lot of times that infrastructure-based isolation is driven by having potentially really dangerous functionality that's necessary based on what kind of service they're providing. To then make sure that there's some level of control outside of just the application. And yeah, for those cases, obviously testing the application is super important, looking for that RCE is super important, but doing that test from the compute instances and doing it from, especially if you have a multi-cloud environment with Azure and GCP, a lot of these things still apply, different names, different services, but you still can do a lot of these attacks, doing it from all those perspectives and seeing what's going on there. Perfect. Next one here, and I'm actually going to hand it over to my colleague Miguel, who's going to talk through some attack paths that he's seen and he's familiar with regarding actually pivoting from on-prem. So it's kind of interesting. One of the downfalls of if you're very heavily cloud focused, we've seen a lot of people focus all their energies on, hey, well, let's look at the cloud environment in a vacuum. But oftentimes, even if people aren't in the office now, you're still on a VPN, you're still connected to some on-prem infrastructure, and oftentimes, that can be used to target other things that can lead to kind of a set of dominoes falling that can lead to total compromise of the cloud infrastructure. So I'll go ahead and hand it over to Miguel to talk through that.
Yeah, thanks, Kevin. So like Kevin mentioned, there's a lot of things that like on-prem, security on-prem, whether good or bad, has an impact on the cloud infrastructure. And a lot of people think that they're isolated and there's no way you could pivot from on-prem over to, wait, did I move that? Or...
Nope, that was me. I tapped the scroll wheel. Okay. Sorry about that. Carry on.
Yeah, no worries. But yeah, there's a lot of things on-prem that can affect the cloud security. So one of the big things is, developer workstations. So developer workstations are a high-value target for attackers because they have a higher chance of having sensitive data or valuable data on them that you could use to pivot to the cloud environment. So for example, SSH keys are a big one. A lot of times when someone gets access to a system, they'll quickly look through PuTTY or just see if they have any SSH keys lying around and on their desktop, documents, or other known places. Now, if those SSH keys, don't have a passcode protecting them, or if they do have a passcode, but it's using the same passcode as their AD password, they can still be used to, pivot to the cloud environment. And on top of getting that remote shell, something like SSH can also be used to create proxy pivots. So if you could create a proxy pivot, you can essentially be on that cloud environment and start using, start tunneling your other tools and applications through that proxy pivot and start spreading, moving laterally throughout the cloud environment. And that's something that, maybe not might be apparent. You might think, oh, it's just SSH keys. You could just log into a system, that account's locked down so they don't have root. It's not only access to the system that's the danger. It's also that, potential for that proxy pivot and for you to get a view of other machines in that environment. Another thing that affects, another on-prem thing that affects cloud security is DevOps and automation infrastructure. So unauthorized access to infrastructure like GitHub, we can use that to search for hard-coded credentials Now, a lot of the times I know developers, they use either dummy credentials or credentials, that aren't valid. But sometimes in the rare instances, you will find valid credentials. And even if they're not valid, you might find that the password is like the default temporary password that everyone uses in the domain, like when they just want to do something temporary. And you can use that default password or that password found in that on GitHub and use that on like a password spraying attack and see if any accounts are using that like temporary or default password. Other things like Splunk and Jenkins can also be abused to get remote code execution on systems. I know Kevin has a blog post on Splunk and how if you misconfigure or if you have the forwarders configured running as root, you can essentially get like a root shell on all the forwarders and instantly pwn everything. Service accounts are another thing on the automation infrastructure that are often forgotten about. So they tend to be used across domains. So something like a backup service account or an SQL database service account, those are usually used cross domains using the same password if they're not being managed by group managed service accounts. And if they're using weak passwords, they're also susceptible to a Kerberos attack. And let's see what else here. So yeah, that moves on to my next point is the shared accounts and passwords. So even if it's not intended to be like by design, even if there's no trust established between the fours, so there's no foreign users that should be able to go from on-prem to the cloud environment, I found that users are pretty lazy at the end of the day. People will reuse passwords, even though an organization might say, no, it's not possible, never happened. It will happen. People just, that's the nature of people. They'll reuse passwords where they can. And then lastly, Azure deployments can have more traditional AD trust relationships with on-prem networks. So kind of mentioned that a little bit earlier. Depending on how they're configured, they could have a bidirectional trust or a one-way trust. And what I mean by that, like bidirectional means, the Azure environment and the on-prem environment have a trust established, two ways. So users from the Azure environment can authenticate to on-prem systems and also the other way around. Maybe it's just a one directional, maybe on-prem users can pivot over to the Azure environments. Typically, this will be like developers. Maybe they need to work on an application, on a database that's on the cloud environment. So those are things that, when someone compromises the on-prem network, they can easily identify with tools like Bloodhound or just by doing LDAP queries and seeing where users, like what groups they belong to. So we have a case study I'll talk about here. So obviously the first step in doing this attack approach from going from on-prem to the cloud environment is compromising the internal network. And there's several ways that this can happen. It could happen through phishing. We've done it by exploiting a web server on the external network, getting RCE and executing our payload that way. Or obviously, also while on internal pen tests, you're kind of given that internal access and you just find a way to exploit it. So recently we were on an engagement for the on-prem environment and the cloud environment, but we started on-prem and we were able to exploit a legacy protocol, so LLMNR, and we combined that with SMB signing to relay an NTLMv2 hash to a system and get remote access to it, to the on-prem system. And after we did that, getting remote code execution on a system, you always find a way to upload your payload and execute it. And once we did that, we started our typical post-exploitation procedure, which is enumerating our user, our system, and getting credentials from the system either by extracting it from memory or using DPA API, looking for privilege escalation paths. Now, in this case, this doesn't always happen, but we were lucky that the compromised user was actually domain admin, so it made it really easy for us to start the DC sync attack and extract all users' NTLM password hash. But again, that isn't always the case. Sometimes you do have to hop around a bit and start user hunting to get to domain admin. So we can identify the Azure domains or targets a few different ways. One of the ways is by looking through the system's DNS cache and seeing if there's any Azure systems on there or any AWS systems, whatever cloud infrastructure they're using. You can also look through, dev users web browser and seeing what web applications they've been hitting, or you could also do it through OSINT just by, going on the internet and getting an overview of the target or the client's network, seeing if they have any infrastructure up in the cloud. And you could also do it by just, seeing what domain trusts are established, seeing if there's a bidirectional or a one-way trust established there. So now on this engagement, on this case, like I said, we were doing a pen test for both the on-prem and the cloud. So the client actually informed us of the Azure environment. So it made it easier. We knew where the environment was and what systems to target. Sorry, just taking a sip. So with that access and the information we collected from step number 2 that I mentioned was doing the DC sync attack and extracting credentials, we were actually able to do a password spray, a credential stuffing attack, actually, not a password spray, credential stuffing, and seeing if any of the accounts were reusing their passwords. And what we found is that, the service accounts, like the SQL service account, was actually reusing the same password, and a select few admin accounts were also using the same password. So with that, we were able to compromise the cloud environment and again start repeating the process of extracting credentials and pivoting to other systems. And eventually we got to domain admin on the cloud environment. So this gave us access to the domain controls on the environment, the cloud environment, and also the SQL databases on the cloud environment. And the importance of, doing a test on both the on-prem and cloud environment at the same time is pretty important. So if we were only told to do an on-prem exercise or a cloud exercise only, it's possible that we would have missed this attack path and maybe left it there for someone else to exploit in the future. So doing them at the same time really gives you the big picture and lets you know, okay, is it possible to pivot from on-prem systems over to the cloud environment? And it is possible. It's a lot more likely than people think it is. A lot of clients think that they're just isolated, two different things. People think that the cloud is this super secure environment and it's impenetrable, but we're not there yet. Sadly, on-prem security still has a pretty big impact on the cloud infrastructure, even if they're not directly tied through like domain trusts. So there's a few things that can be done, to harden and test security controls in place. So as I mentioned, performing the internal pen test or red team from the on-prem environment with the goal of targeting the cloud environment. Sometimes a client, will want their cloud environment tested and tell us on-prem is out of scope. And, that has its place, either for compliance reasons or you really are just interested only in the security posture of the cloud environment. It's also worth testing against the cloud environment from the on-prem network to see what's possible and identify any security gaps. And we recommend, performing them together at the same time, and if possible, providing the information to the consultant to make it easier and communicate with them what you want out of this engagement to like align efforts more closely to what the goal is. Number 3 is, review DevOps infrastructure and what developers have access to. So one of them is, reviewing their group permissions for AD, seeing what they have local admin access to. I've seen developers have local admin access to, 20 machines. And while that makes it easier to get your day job done because, you could just be local admin, do whatever you want on the system, it does create a pretty big attack path and like a way to pivot from one machine to another machine. So what we recommend, is just give developers access to, well, if they don't need local admin access, don't give it to them. That goes for every user. But if they do, give it to individual users onto an individual machine versus giving the entire group, local admin access to all the machines. And also review your infrastructure. So as I mentioned, Splunk has some vulnerabilities if you have it misconfigured. I would recommend reading up on Kevin's blog post and seeing some of those misconfigurations and making sure that the forwarders aren't installed, running root, using under root, making sure if you guys have Jenkins installed, make sure that the Groovy console is disabled, stuff like that. Just making sure the infrastructure doesn't have any security gaps in it. GitHub also, if you guys have, I'm sure you guys have a lot of scripts on there or clients have a lot of scripts on GitHub. Make sure the credentials that are hard-coded in there, that they're either placeholder dummy credentials or they're credentials that are just for that one application and it only has read access and they can't be used to move laterally or escalate privileges. Step number 4 is phishing or doing purple and red teaming tests targeting developers. A lot of times when we do these purple teams, uh, they'll want to give us an account that's isolated, maybe, minimum permission, maybe just a domain user. And that doesn't give you the full picture. While I do like to test from that perspective, but also want to test from, someone who's a little more privileged, like a developer, because that'll give you the bigger picture. Well, what happens if a developer gets compromised or through phishing or something? And even if it's not through phishing, what if they get compromised through a 0-day? Like, it's kind of a joke sometimes. 0-day can happen to anyone, but as we've seen recently, there's been a lot of new 0-days that have come out, and they are affecting a lot of companies. And so it's something to take into consideration when planning these purple teams and red teams. You want to make sure that you're getting an accurate picture of what's possible and not just doing tests from contained or isolated users or environments.
Excellent. Yeah, thank you, Miguel. So yeah, it's pretty interesting, obviously putting a firewall between, as in, just a network firewall, but a a solid firewall, air gap barrier, whatever you want to call it, between on-prem and cloud. It tends not to be totally realistic, and in many cases isn't the case. Yet at the same time, a lot of times it's treated that way when we see people looking at how they're thinking about their security of their networks and they're doing threat modeling. It's not something that necessarily is a bad thing, right? By design, you probably, if you have an internal network, you're going to have, some kind of federated identity, developer workstations on that network, getting access to, DevOps resources. It's just the way things tend to work, but it's just something that's really important to be aware of and something to make sure you're covering when you're doing your pen testing regimes. And, particularly doing them together can be helpful rather than doing siloed tests. There are obviously considerations, like we mentioned, for the cloud infrastructure. Those are different than the considerations for the on-prem, but just knowing there's those links, right? Whether it's where, the Terraform server is, and developers' workstations logging into and running Terraform, or the Jenkins server that has access to orchestrate pushing builds out, or if it's just things like maybe even have a separate kind of developer environment that's separate from AD, but then maybe they're all on Macs and you have a Jamf console, and the Jamf console is used to orchestrate the Macs, and that's tied to the more standard IT infrastructure. There tends to be a lot of those little links that we look for, and it's good to be aware of where those are in your network, regardless of any pen testing, and just understand that, hey, you're not necessarily going to be immune. These environments aren't necessarily, because of the way an organization works and people need to have access to multiple things in the organization, they're in most cases not going to be as siloed as you might expect or may just kind of assume if you're treating them that way. So it's always something good to be aware of, and make sure that you are taking, again, maybe an overused term, but a holistic approach, looking at everything as a whole, and understanding how your cloud deployment fits in with your existing on-prem network infrastructure, particularly in context of workstations. And again, developer workstations we've mentioned about a million times, because those tend to have a lot of really interesting things: SSH keys, provisioning artifacts, details of how to log into things. Definitely very ripe targets, very good targets for an attacker. And
PowerShell history.
yeah, PowerShell history, ZSH and Bash history, all that good stuff. Oftentimes, just seeing what they do on their day-to-day and what their day job is enough to figure out, well, okay, this is how they log into the server, and kind of piggyback off that. And again, it's just how that works, right? So it's something to be aware of, and something to be cognizant of, and the reason why those things are such good targets. Perfect. Well, we did also want to mention, that's kind of the three key things that we've seen and wanted to go over, but there are some specific miscellaneous shout outs I want to give out, and this one's not directly related to cloud, but oh man, is this something that is really hitting people hard lately. So if everyone isn't familiar, there was a great blog post kind of end of February, I believe, early March, about dependency confusion. The title was great. It's basically how I hacked into Apple, Google, and others. But essentially, there's a lot of build systems that really are poorly designed from a security perspective. NPM, PyPy, and things that help orchestrate those and host internal repos like Artifactory. The problem is that essentially a lot of these, when they're looking for what package to get, they put a huge amount of weight on the version number. So as this nice little meme here shows, JFrog Artifactory trying to decide which package to install, it's going to have maybe something in an internal repository that's version 1.0. But if that internal library isn't registered in a public repository, it's actually very easy to register. I could just go on npm right now and just register any names that don't already exist, or meet some very rudimentary mapping overlap rules. So essentially, what attackers will do is they'll try and figure out what internal libraries are in use at your organization, looking at things like GitHub and GIS, and you'd be surprised where a lot of these things can leak out. Doing OSINT to discover what some of these packages and libraries may be to target. And what they can do is register these names on a public repository, and that is then going to basically, if they have a higher version number, a lot of the automation is going to dutifully look to that higher version number and say, oh, well, I've got a better one on the remote. I'm going to go ahead and grab that. And so you end up with, especially in things like cloud deployments where a lot of this stuff is automated and you're pushing these things out, you could end up with wide compromise of many systems. And this also is an issue even if you're maybe not tied into Artifactory. Let's say you have repos that developers are just cloning locally. If they're using not absolute file path names to those internal packages, if they're just doing the package name and relying on npm, for example, to resolve that name to a local directory that they're running from, that's not a registered instance on the public repository. Someone could register that instance and now shadow that. And every time a developer installs something, it's basically running that arbitrary code from whoever registered the public repository on their computer. And this has been pretty scary. I mean, especially, we've seen a lot of customers that use Artifactory to handle some of these repositories. And, now it's a situation where, yeah, not only is it a config change, but you have to patch Artifactory in order to support some of that configuration change to put these new security features to tell it, hey, don't go to the public repo first. There are some ways with rules that you can do it without patching, but, a lot of customers have been running into issues of, wow, okay, I need to patch Artifactory. Maybe we're on an older version because of issues we saw. It's something where it can be pretty tough to get that rolled into production. But that dependency confusion, that's just one thing, and that's something that's very specific, very damaging, and very widespread. And so that's why I'm calling it out here, especially for people that are in the cloud and do have DevOps infrastructure, because that's where it tends to hit the hardest and be the most relevant. Although not directly a cloud issue, it's something that certainly is relevant for most cloud deployed applications and environments that we've seen. But the supply chain attack thing is something to always be aware of. The repositories out there, I mean, it's amazing how much we rely now on npm and PyPy and Golang and all these resources for these repositories that actually aren't well hardened against supply chain attacks. And again, dependency confusion was a great attack, taking advantage of really a not really ideal model for downloading these dependencies as far as the decision tree for where it goes to get an internal or a public dependency. But there are also, again, these are public things that are out there, relatively easy to register accounts for. Things can go stale and get taken over. There's just something to be really aware of from supply chain attacks. And so you want to be careful on how you are rolling this code into your production instances. And do you really want to be just, referring to public repositories in general? Maybe you want to, get known good ones and put them into something like an Artifactory and then go off local repositories. But again, it's super important. You want to make sure everything is configured such that you are for sure pinning your internal repository and not going out and downloading something elsewhere. Yeah, I could talk about this thing for an hour on its own, but just wanted to give it a shout out here on this because I know it's going to affect a lot of people. And if you're not aware of it, make sure you are, and make sure you read this Medium blog post. There's a really excellent job on kind of explaining, not only one, how it works, but two, how, they're able to rein in shells from Apple, right? So very, very impactful type of attack. One thing I did want to mention as well is just compliance considerations, specifically PCI. I don't know if everyone on the line deals with PCI, but if you do, it's a little bit of a nightmare mapping database sometimes because they have a very prescriptive set of requirements around, how you map your network, and those were obviously designed in, 2008. It's all geared towards on-prem, right? So you do have to do a little mental model mapping. You may get frustrated when you go through a PCI assessment and, we're asking for things, or whatever auditor is asking for things that make more sense for on-prem. The reason is you have to do that mental mapping somehow because it's something that's required for PCI. So just something to be aware of in the scoping there. You need to figure out, okay, what are my internal network zones? Maybe that's just the VPC ranges. If I'm looking at my host names or my scope for the external, maybe I just do an EC2 describe instances or a list of all my ELBs or whatever dump it may be to get that point in time, because obviously that can scale as you're scaling EC2 instance or whatever it may be, and those IPs may be ephemeral, so you're not going to have a traditional scope. So just one thing I just want to give a heads up that if you deal with compliance standards, sometimes you do have to do a little bit of wrangling to map that into what the standard wants, which may have been designed in a more of an on-prem world. So just some frustration. It's coming your way if you are doing some of these compliance things, particularly PCI, but it's just something that luckily that mapping can be relatively straightforward once you just get over the hurdle that it doesn't necessarily make sense or is the most optimal thing to do in an AWS world. Some other considerations I just want to touch base on are, monitoring, response, automation around security. So, one of the great things in cloud deployments is the automation, right? And the services you can leverage to automate things and deploy things and have things orchestrated. That can apply to security as well. I mean, obviously that's a big force with things like Phantom.js and in security world as a whole, but a lot of things actually have native support for some automation based on logs, right? You can do things like look for, hey, if I ever see certain calls being made from that IAM instance role, even attempts, quarantine that system and image it and send it over our team to IR, right? Things like that are really powerful for monitoring and alerting that help you get in front of some of these issues and not only know, hey, someone's, we're blocking this, but hey, someone's trying to attack here. Let's have a process spun up where we can go see that happening, do the forensics, and prevent a wider issue from happening, and just shut it down. So something that's definitely really interesting here to explore. The other component, auditing, pen testing is a really is great, right? Because you're coming in and seeing an attacker perspective, and I know what I was talking about was almost leaning into the auditing side when we're talking about having read-only access to AWS, but there is also something to be said about doing kind of a pure audit of how is this thing architected, right? What is your expected security model? Different than a pen test, more on the conceptual level, as well as diving into some of the technical details on the dials and buttons. But that can be a really valuable process as well. I'm not sure, we might have one of our members from the cloud team, Chris, on the line who can speak a little bit to that. Chris, I don't know if you want to give a plug to some of the auditing and some of the things that that are really important when you're looking at making sure a cloud deployment is secure.
Can you guys hear me okay?
Yep, loud and clear.
Okay, perfect. Yeah, I mean, we get brought in on the cloud side during various phases of organizations' deployments. Either they have something pre-existing or they have a brand new workload or they're migrating a workload. Auditing is super important. Where it gets tricky, so on the AWS side, they have a CloudTrail, which is all the API activity. Another thing that we see people generally don't review, or some of the technology out there doesn't pull them in, are like the VPC flow logs, but it's important to be able to translate outside to inside type activity. And then depending on the technical components that exist within the environment, so if you have like EC2s or something like that, you want to make sure that you're pulling like syslogs off and you have that in place. Something that we, people kind of get overwhelmed with the amount of information that's coming in. So it's important to be able to kind of like get that needle in the haystack, because before, you maybe had like hundreds, thousands of systems, but now things are scaling like tens of thousands of systems, or everything is set to auto scale. So how do we know what is going on? So we see like a lot of, ML tools like TensorFlow starting to get leveraged with our clients to start helping pick out that needle in the haystack. And that's been proven really beneficial in order to, they call it like TFX pipelines. And so you could start importing things like your VPC flow logs in there, and it could start pulling out irregular activity. So we're seeing some of those developer tools that were generally used to like identify like bad deployments and troubleshoot, but start getting leverage more on the security side, which has been really exciting. And also distributed tracing technologies like OpenCensus. There's a lot of really neat stuff that you could do with AWS on that end as well. But whenever we're helping organizations architect, we are a big believer in keeping people away from production, keeping people away from data. But what we run into is things are done more and more as code. And, whenever we're going through an audit, we'll call something out and we'll be told, hey, this isn't going to be in production. But more times than not, especially when we see that there's a follow-up pen test on a production environment, it's generally identical. Sometimes some of the credentials, are actually rotated, but, you dig into GitHub a little bit, you'll find a mapping file and there'll be a whole bunch of stuff that's actually carried over that ends up giving our threat team, leverage to, not only compromise potentially like systems, but also the, the AWS environment itself. And the only other thing I wanted to touch on is like system access. That's something that we bring up quite a bit is not just like, SSH keys, but also, AWS access keys. Those have a tendency to kind of go all over the place. And, once one of those administrative workstations are popped, a lot of those keys that we see, especially like on like a developer type system, that they're going to have administrative access there. So starting to put into practice things like dynamic credentials, they get checked out and they rotate, it's kind of like an STS token. They get rotated like every single hour. So even if they do exist, if that system is compromised, well, apart from, access and being able to request that key and have it generated, that limits, kind of like the fallout a little bit, but then also people using things like systems manager. So then you don't have any like SSH exposed, or there doesn't need to be a connection potentially from a corporate, if it's not a hybrid, but if it's just a cloud native environment, there doesn't need to be like that type of connection that exists, and they have to go through the authentication side, and then they get dropped into a shell via systems manager. And we've seen that be pretty successful as well. And yeah, it all comes down to the technology components and what's in use. So, get really granular on those, like, those S3 policies or any of the policies, and really get granular on, the conditional access side of it. I think it's like, some of those XAML bucket owner type policies, enforcing TLS, and getting really granular, just not from like a, who should be accessing. Some of the times, something that we've seen is, the greatest form of segmentation is at the actual account level. And we'll see things are kind of called, authorized from an organization level to an S3 bucket, but get even more granular. It says what specific role, what type of access should be coming in here to perform this actual action. Because if there is a compromise, it could lead to that account kind of takeover type scenario. And just a couple high level things, Kevin, from my mind, that from the items that you've been talking about.
Awesome. Yeah, thank you, Chris. Perfect. Well, I think that's a good way to wrap it up.